Okay, welcome to the solutions video for assignment 6.06 number 2. So in this one, we are going to be solving an easy difficulty killer Sudoku, because there is nothing easier than easy. So here is our grid. Again, the key starting points are to look for squares or regions that only have one option. So when we fill these in, if I could find just the right place to frame it, we'll be able to click on all the numbers. So we fill these in first. And in doing so, we've filled in some of the blanks. Now our next best bet is this bottom left 3x3 square here, because we only have one square sticking out. And all the squares are the sum of 1 to 9. They have to add up to 45. So let's add up 22 plus 10 plus 5 plus 16. So if we add up all these regions, we get 53. But just these add up to 45. 53 minus 45 is 8. So this number has to be an 8. We can use that same logic. All of these have to add up to 45. So if we take 8 plus 12 plus 12 plus 4, we get 36. Therefore, this has to be a 9, because it'll take 9 more to get this whole thing up to 45. Now these two add up to 15. We already have 9, so there's only 6 left. We can do similar tricks to fill in some squares here. The upper right, we've got all but this one contained within it. 3 plus 19 plus 13 plus 9 is 44. So we only need one more to get up to 45, which makes this a 4. If we look at this column, that'll be similar, because this entire column is again 1 through 9. So again, that adds up to 45. But this zone is entirely in the column. This zone is entirely in the column. This one has one box sticking out. So if we add up 5 plus 12 plus 6 plus 3 plus 4 plus 17, we get 47. That's 2 too high, so we must have a 2 right here. This also helps narrow down what we have in these spaces, because if we can't have a 2, there's only 2 ways to add up to 5 without repeating. It's either 1 and 4 or 2 and 3. It can't be 2 and 3, so these two cells have to be some combination of 1 and 4. Similarly, the only way to make 3 out of 2 numbers is to have 1 and 2. The only way to make 4 out of 2 numbers is to have 1 and 3. We can do better than that now, because we have to have a 1 up here. We have no choice. So we cannot have a 1 down here. So that one's only 3, and that's a 1. We can make the same argument here. If we have a 2 in this row, this 5 cannot be 2 and 3. So that has to be a combination of 1 and 4. 22 minus 8 is 14. There's only 2 ways to make 14 with 2 numbers in killer Sudoku. It's either 5 and 9 or 6 and 8. It cannot be 6 and 8 because we already have an 8. So therefore it must be a 5 and a 9. Because of this 9 here, this one can't be a 9. That one has to be the 5, and this one is the 9. So we are slowly chipping away. There's only one way for 2 numbers to add up to 4 without repeats, and that's a 1 and a 3. So we'll have the 1 and the 3 over here as well. Looking for other unique combinations. We know that 3 numbers that add up to 8 have to have a 1. Because if you have 2, 3, 4, the 3 smallest numbers you can have that don't include 1, they add up to 9. So we have to have a 1 in here somewhere. Similarly, this one, this 12 block has to have the number 2. Because we're not allowed to have a 2 in this or this or this. And to make two numbers add up to 12, one of them has to be at least 3, because it's 3 plus 9. You can't have a 10 for a 2 plus 10. So one of these is the 2, which means we have 2 in the bottom 2 rows in the first cell. We have 2 in the bottom 2 rows in the second cell. So the only cells up here that are allowed to be 2 are these ones. So again, we are slowly narrowing down what we have. Let's take a look up here, because that one is quite narrowed. Sorry if I seem a little scattered. I couldn't preview the puzzle that it was giving me. But to make two numbers add up to 12, we either have 3 and 9, 4 and 8, which is not allowed because of this 4, or 5 and 7, which is not allowed because of this 5. So therefore, this has to be a combination of 3 and 9. There's no other way to set that up. Which means down here, the only two numbers left that aren't accounted for are 7 and 8. So now we must have a 5 here, because we have to have a 5 in this 3 by 3 block, and we already have a 5 in that row. And we must have a 6 here. That tells us this number is a 7. So this cannot be 7, that's an 8, and this is a 7. So we have 1, 2, one of these has to be a 3, and one of these has to be a 6. Now the 3 in this column is spoken for. In fact, the 3 in this row is spoken for. This cannot be a 3, therefore that's a 1, and this is a 3, which means this has to be a 6, and this has to be a 3. So the rest of this column would be a set of, or this zone, would be a set of 3 numbers that add up to 24. That's 3 numbers that average to 8, where 9 is the highest number we can have. So these have to be 7, 8, and 9. We cannot have a 7 in this 3 by 3 block because we already have one here. So that's our 7. This cannot be a 9 because we have a 9 here, so that's our 8. And down here we have our 9. So we can do our trick of forcing these 9 cells to add up to 45. We know these add up to 15. So we have a 15 plus the 9, 3, and 8, the 1, and the 7. These add up to 43, means that has to be a 2. Which also means the only numbers left here are 1 and 5, because they have to add up to 6, and mostly because we know that 8 has to have a 1 in it somewhere. So if we have a 1 and a 2, that adds up to 3. 5 is the only number left. Which means this is the only option for the 5 down here. So that has to be the 4. So as we can see, with process of elimination, we can really build things out. We only have 2 numbers allowed here. It's the 3 and the 7. So once we finish our deductions, we're going to be able to prove that one of these has to have at least the 3 or the 7 in it. It can't be a 3 in the 12, because that would require a 9, and we'd already have the 3 up here that would conflict with it. But that doesn't mean we're not going to have the 3 show up above in the 18. So horizontally, there's only 3 cells left here. It's a 2, a 6, and an 8. We can't have an 8 here because of this 8. So 2, 6, 8, and 2, 6, 8. So let's come up here, because now we have another cell in the 3 by 3 grid with only one unknown, or one square whose total is unknown. We know these add up to 6. We have a 3, a 7, a 4, and 17. So these cells add up to 37, which means this highlighted cell has to be an 8. It has to be, so we don't use the pencil marks. So now looking at this column, we have the 1 somewhere here, 2, 3, 4, 5. So these are going to be the 6 or the 9. That immediately tells us that we're going to have a 9 in the top row up here, it cannot, and that's because we have to have a 9 in the bottom row here, and we have to have a 9 in the bottom 2 rows here. But because we have a 9 in this column and a 9 in this column, it has to be there. Now we can come back here. The 6 and 9 add up to 15. So this has to be what remains. It's got to be the 4. So again, we are chipping away at what our options are here. Let's look at the ways we can make two numbers add up to 9. It's either 1 and 8, which we can't have because there's already a 1 here. It's 2 and 7, 3 and 6, which is impossible, or 4 and 5, which is impossible. Therefore, this 9 is 2 plus 7, and we have a 7 here. So the 7 has to be in this column, and the 2 has to be here. So that leaves us with an 8 and a 5 left in this 3 by 3 square to make 13, with an 8 already in this column, and a 5 already in that column. So this, typo, that's an 8. And this is the 5. So now we can figure out exactly what number this is, because there's only one square not filled in. Process of elimination says that must be a 6. These two have to add up to 11. They are 2 and 9. Because we have a 9 here, this one has to be the 2, and this one has to be the 9. So again, we are slowly but surely trimming these down. So this row needs both a 5 and a 7. Because we have a 5 in this column, the 5 has to be here, and the 7 has to be here. These add up to 15, so we need two numbers here that add up to 7. It cannot be 1 and 6. It cannot be 2 and 5. Therefore, it's got to be 3 or 3 and 4. Because of the 3 in this row, that has to be the 3. This has to be the 4. So the only numbers left unplaced in this grid are 8 and 9. So if we make that comparison to the other grids, we know which order they go in. With this, we can now determine what number goes here, because we've got 1, 4, so 1, 2, 3, 4, 5, 6. We are missing the 7, so we have to have a 6 here to make these add up, which means this cannot be the 6 and must be the 9, and that becomes a 6. And if we have a 9 here, this one has to be a 3, and this one has to be a 9. So the only numbers left in this cell are 2 and 8. Well, we have a 2 and we have an 8 in our next section to block those off. So we have a 2 and an 8 here. So we have largely solved the two sections on the right. Let's take a look at what we have left. So up here, this is a 9. So these two numbers add up to 8. We have a 5 here, so it can't be 3 and 5. It cannot be 2 and 6 because we have 2's in these spaces. So the only options left are 1 and 7, but we have a 7 in the top row. So that is a 1, and this is a 7, which means this cannot be the 1, which makes it a 4. This cannot be the 4, which makes it a 1. This cannot be a 1, so that's a 3, and that's a 1. So we've solved this chunk. There's now only one cell left across the top row that is unsolved. That must be a 6. So these two numbers have to add up to 12. Notice we have the same problem down here now. If we have a 3 in any of these, the other number has to be a 9, and it's not allowed to be a 9. So none of these 4 cells are allowed to have a 3. Of these 3 cells, only one is allowed to be 3. That has to be the 3. This has to be the 7. So the ways that we're going to add up to 9 without the 3 are either going to be 4 and 8 or 5 and 7. We have an 8 here, so we can't have a 4 and 8 in this combination. It has to be 5 and 7 with a known 7 here. Makes that one the 5. And this one the 7. This can no longer be 5, so it must be 1. That's a 5. If we have a 1 here, this has to be a 2. That's a 1. There's only one number left to solve in this row, and that is the 6. That's the only unplaced number. So these have to be a 2 and a 4 in some combination. And we can actually tell which it is right now, because this is a 1. So this cannot be a 1. So that has to be a 4. This has to be a 1. So this cannot be a 4. It must be a 2. And that's a 4. Now this cell we earlier determined was either 2, 6, or 8. We now have a 2 and 6 in the column. So that's an 8. This was either 2, 6, or 8. It can no longer be 8. It can no longer be 6 because of that very top row. So this has to be a 2, which leaves this as a 6. Now all the empty squares are in the top left, 3 by 3 grid. So there's only one way or one place to put any given number. You already have the 1. We can't have a 2 in the top row, the right column or the left column, so this has to be the 2. We cannot have a 3 in the bottom row or in the right column, so the 3 goes here. 2 plus 3 make 5, so we need a 5 to make the 10 here. The 8 goes here, and the 4 goes here. This concludes the homework for 6.06, number 2.